Hi, I'm Dr. Jim Zoval, a professor of chemistry at Saddleback College. You're about to watch one of my video lectures. If you like this lecture, you can get the entire Allied Health General Organic and Biochemistry course from the website address you see on the screen right now. Be sure to type the underscore between VOD and pages in this address. Enjoy the video. So let's talk about what is a mole. That's a mole right there. These things dig around in the dark tunnels, and they have those nice claws and really good senses of smell. But that's not the kind of mole we're talking about. That one right there. This is an older picture. I see when I'm at the sport club, I see her doing a lot of advertisements for this beauty kit. That's not the kind of mole we're talking about. What's that? Mole. Yeah, I had someone in another class that thought that that was this guy cooked up. I know. No, we don't do that. So not that one. I don't think that one either. Here's the star-nosed mole. Very good sense of touch as they dig around and feel for food. Those are the wrong moles. We're going to talk about what's called the chemist mole. Atoms are so small and they weigh so little that it's not convenient to work in the lab and talk about how many atoms and these other things we'll talk about called molecules, how many there are. They're just so light and so small. It's better to work with a larger quantity of them, about the amount you could put in your hand, which is what we call the mole. To give you an analogy of a mole, bakers do the same thing. When they are buying eggs, they never go and buy one egg at a time, right? How do they buy the eggs? By the dozen. So think of the mole as how we get our atoms and molecules. We'll get them by the mole. It's more convenient that way. So mole is a counting unit used for atoms and molecules. Count just like a dozen is just a counting unit. That's a unit. I'll give you a couple other examples of pure counting units. They don't depend on what you're measuring. Feet is only for distance. Can you guys think of any other counting units? What if you're going to count two things? What do we call that? A pair or a couple. How about three things? Or few, right? So a counting unit, a term that refers to a specific number of things. Couple. A dozen. Here's how many in a mole. So it's just like 1 dozen is 12, a couple is 2, a few is 3. 1 mole is this many, 6.022 times 10 to the 23rd. That's a really, really big number, but that's about the amount of stuff that would fit in the palm of your hand. This was named after a chemist who did some work a long time ago on gases and finding out how many gas molecules are in a certain volume, Amadeo Avogadro. And so he didn't discover it. It's defined, but it was named in his honor. The definition of a mole has to do with carbon-12. It's the number of carbon atoms in 12 grams of carbon-12. Just to give you an idea how big a number that is, it's hard to get we're good at understanding numbers that we're familiar with. As we evolved, we got good at knowing, about the number of people in our village, maybe, about 100. We get a feel for how many 100 is. And maybe if you farmed, you had 1,000 cows, so we could get a feeling for 1,000. 10,000, well, just imagine 10 times that much, right? 100,000, well, it starts to get big, right? The number of people in one of these big stadiums. When things get much bigger than that, and that's only like 1 times 10 to the 5th. When you start getting into 1 times 10 to the 7th, 8th, 9th, 10th, the number just gets so big it's hard for us to get a feel for how large a number that is. If you had 1 mole of marshmallows, that would make a 12-mile thick marshmallow layer over the entire face of the earth. So whole 12 miles thick. That's 1 mole of marshmallows. If you had the popcorn, not pop, but the kernels, that would cover the United States, 9 miles thick. This is a good one. If you gave everyone on the earth 1 mole of pennies, right, they could spend $1 million per hour, every hour, day and night for the rest of their life. This is an old cartoon when I was a kid, Richie Rich. I don't know if he's around. Here is 1 mole of water molecules. So you compare this difference relative size between marshmallows, whole globe, 12 miles thick or something like that, versus that much, about 20 milliliters of water. 1 mole. That's how tiny these atoms and molecules are. And since that's about the amount that fits your hand, it's convenient to work with things on the order of a mole when we do things in the laboratory. So we'll talk about how many moles of carbon atoms or how many moles of water molecules. 1 mole of anything is Avogadro's number of those things. You could have a mole of carbon atoms. You could have a mole of oxygen atoms. You could have a mole of water molecules. You could have a mole of marshmallows. It's just a counting unit. It's named after Amadeo Avogadro, fine-looking gentleman. This haircut's now coming back in style. I saw some of these kids, they do that. Anyone wearing one? I won't call you out on it. I don't see any here. That's how many it is. Here's some examples. This is about this big. This is 1 mole of lead, 1 mole of silver, 1 mole of powdered copper. Some other things. There's 1 mole. It's a mole of iron, and that is nails. Understanding check. How many atoms are in 1 mole of helium? How many? Anyone? No one? I'm gonna get another job. Help me out. Yeah, 6.022. It was just too easy. That's why you guys didn't bother. Okay, good. I was worried about you guys for a minute. Or about me. Yeah. So it's a standard counting unit. It's the relationship between number of atoms or number of particles and moles. And so we could convert back, and we'll have to do that at times, convert back between number of atoms and number of moles. We have the relationship. It's Avogadro's number. We're going to use our conversion factor method to switch back and forth from number of atoms to number of moles. There's that relation. We could convert between any 2 units if we know the relationship. This is the equivalent statement. 1 mole is 6.022 times 10 to the 23rd. How many significant figures here? 4. Mm-hmm. And so we could write that as a conversion factor. Oh, by the way, the abbreviation for mole is MOL. We're trying to save work, but we can't do M because we got that. We already got the meter and milli. We can't do MO because if you look in box number 42, MO lives in there. There's Mo, molybdenum. And so we abbreviate MOL. So you could either write MOLE or you could abbreviate it MOL. And write those as conversion factors. And now you could convert back and forth between number of atoms. When we do molecules, it'll be the same thing. Number of molecules or number of marshmallows. Between moles and number of particles. So here's a little conversion map. If you're given the number of atoms and you want to know the number of moles, you're going to use Avogadro's number as the conversion factor. One way or the other, depending on which way you're going. When you're going from atoms to moles, you want atoms on the bottom, like we were doing in lab last time. When you want to go from moles to atoms, you're going to put moles on the bottom, so moles cancel. Let's do a practice problem together. Let's do some conversions. Here's a 1931 Rolls-Royce convertible. So get your calculators out. And some of you guys learned how to do scientific notation with me when you're doing problems on Tuesday in the lab. Some of you haven't done scientific notation yet. Some of you who haven't made it to the store and trying to get by on your phone are in big trouble now. How many carbon atoms are there in 0.100 moles of carbon. So just like we did our other conversion, we want to convert from one unit to the other. We want to convert from the units of moles to the units of atoms. So we need to know the relationship between moles and atoms. We have it. That's Avogadro's number. So we're going to do that. We're going to write down what we start with. Remember, what do we do first? We write down what we're given, 0.100 moles of carbon. And before I do this on the screen, I want to just show you an intermediate step here. So 0.100 moles of carbon. Now, I know I want to convert from moles of carbon to carbon atoms. That's the question. So I won't even worry about the numbers right now. I'll just put the units. I know I want moles of carbon here, and I want to convert to carbon atoms here. Now this tells me I need to know the relationship between moles of carbon and carbon atoms. That's Avogadro's number. Where do I put the 1? With mole or with atom? Mole, because 1 mole is many, many atoms. Don't flip that over. Don't put that 1 atom as Avogadro's number of moles. 1 mole is Avogadro's number of atoms, which is 6.022 times 10 to the 23rd. Now I'll do the dimensional analysis. I'll cancel moles. I'm left with carbon atoms as my unit. Good, that's what I'm trying to calculate. Now, you're going to do this on your calculator. I know your math teachers wanted you to do it in your head, but in here, I'll assume you mastered that, and you're going to save time by doing it in your calculator. So get your calculator out, and if you get ahead of me on your keystrokes, you might get it wrong. So go stay with me, and I'll tell you the keystrokes you should do on your calculator. So start by entering this number just like you're going to do this times this. So start by entering this number. So 0.100. And now you're going to multiply it by this. So do your times sign just like you always do. Now I'm going to teach you something that might be new for you, how to enter this number in scientific notation in your calculator. So you're going to do 6.022. Now don't do anything after that 2. Now you're going to press a button, and on some calculators you'll have a key with an E above it. If that's true, then you're going to press the button in the upper left-hand corner like shift or second function, EE. Shift or second function, and that. Some of you might have a key that says E. Some of you might have a key with EE on it, then you just press EE. Some of you might have a key that says EXP, and some of you might have a key that says times 10 to the n. Okay? So once you've pressed all those, what that button is that button is this part. You don't press times 10 again. That's built into the key. If you do this, it's going to give you the wrong answer. Then you'll press 23, and then you'll press equals. So 0.100 times 6.022, either one of these or second function EE, then 23 equals. And when you do that, you should get that. Now your calculator might just say, it might say it might just say that. You have different calculators. All right, we got it? Questions on this? Hi, I'm Dr. Jim Zoval. If you like this video and you'd like to get the entire course or just some of the chapters on video, I have the entire course in video lectures at the website you see on the screen right now. They're available on demand. The period of the rental is for a full year, so you'll have this video through the entire course. You could watch it as many times as you want, whenever you want. Happy studies.